table shows 400 students at a school, and each student was asked whether they prefer swimming, cycling, or running. And the results are given in the following table. So normally when we see a table like this, first thing that we do is we find the marginal total for each of the table. So when we add column wise, we have 135 students who like swimming, and students who do cycling, there are 107. And after that, we have 158. In total, there are 220 female students and 180 male students. Now, in the total number of students is 400. We always check that the last column total and the last row total is 400. Then we know that our calculation is correct and there is no error. Part 1, we need to find the probability that the students prefer swimming. So in total, there are 135 students who prefer swimming. Then the probability that the students prefer swimming is 135 over 400. So this translates to 27 over 80. Part 2, determine whether the events, the student is male and the student prefers swimming are independent. If two events are independent, say you have probability of a male and the probability of swimming, that should be the probability of male times the probability of swimming, if independent. So if independent, we always have this. What we want to check is whether this is true. Probability that a student prefers swimming is 27 over 80. The probability of a male student, male in total, there are 180 male students. This is 180 over 400, which gives us 9 over 20. Now, probability of male swimmers, male and swimming, there are 31 of them. So we have 31 over 400. Now we want to check whether this is the same as the product of probability of male and probability swimming. Let's look at this. This is 0.0775. And probability male times probability swimming, that is 9 over 20 times probability swimming, that is from part 1, 27 over 80. So this is equal to 0.151875. And this is not the same as probability male and swimming. So in that case, we say that male and swimming are not independent. Part B here, on average at all the schools in this country, 30% of the students do not like any sports. So probability, we consider this as a success. Then we have P equals to 0.3. Probability of success is 0.3, that the students do not like any sports. Part 1 here, 10 of the students from this country are chosen at random. So N is 10. Find the probability that at least 3 of these students do not like any sport. Now, whether a student likes any sport or not is independent from another. And this is an average, so we have constant probability of success, and total number of trials is equals to 10. And we let X to be the number of students who do not like sports. Then X follows a binomial distribution with n equals 10 and probability of success equals 3. Find the probability that at least 3 of these students do not like any sports. So we find the probability at least 3 X greater than or equals 3. That will give us probability X equals 3, X equals 4 until X equals 10. We're not doing that. Use the complement rule. This is 1 minus probability X less than 3. Or we can write this as probability X less than or equals 2. So this will give us 1 minus probability X equals 0 minus probability X equals 1 minus probability X equals 2. Probability X equals 0, that is 10C0, 0.3 to the 0, 0.7 to the 10. Probability X equals 1 is 10C1, 0.3 to the 1, 0.7 to the 9. And probability X equals 2 is 10C2, 0.3 to the 2, 0.7 to the 8. And we compute this to obtain 0.617. So the probability that at least 3 of these students do not like any sports is 0.617. Part 2 here, 90 students from this country are now chosen at random. So n is 90 now, and you need to use an approximation to find the probability that fewer than 32 of them do not like any sports. So if n is 90, probability of success is 0.3. X here follows a binomial distribution with parameters 90 and 0.3. Probability fewer than 32. So we need to find probability X less than 32. Now, obviously, we can't do that. So we will have to use a normal approximation to the binomial, check that the conditions are satisfied. We have 90 times 0.3. This gives us 27. This is greater than or equals 5. And n1 minus p, we have 90 times 0.7, which is 63, and this is greater than or equals to 5. Then we can use a normal approximation to the binomial. So X here approximates Y, which is a normal distribution. We need to find the mean. The mean of a normal distribution is equals to NP here, which is 27. The variance is given by NP1 minus P, or NPQ. We have NP 27, where 27 times 0.7. That is 18.9. That is the variance. So we have 18.9. To find the probability that X is less than 32, when we approximate it by a normal distribution, you have Y greater than, and you must remember to apply the continuity correction factor. If this is less than 32, you must subtract 0.5. That is 31.5. This is a continuity correction. And this is a standard normal, this is a general normal distribution. So we need to standardize using the z-score. We have 31.5 minus the mean and divide by the standard deviation. 18.9 is the variance. So to find the standard deviation, we take square root. And that will give us 1.035. That is a left tail area. So this is 0, this is 1.035. We need to find this left tail area, which we can find directly from the standard normal table, and that is 0.8497.